We're ready to begin our webinar, and I want to thank everybody who's in attendance. Hello, my name is Mark Shinesk, and I'm joined with my colleague John Offield from Seiler Design Solutions. And today's webinar, the Accelerating BIM with Reality Capture. And we're going to co-title this the XGRIDS and Autodesk Scan to BIM show. So we're going to talk about a variety of a particular hardware piece, and this is a for example, but we're opting to showcase this piece of hardware to show how quickly we can take a scan and go into start creating our BIM content. About Seiler Design Solutions, we are part of 5 distinct divisions owned and operated by Seiler Instrument Manufacturing Company. Our experienced industry leaders provide customers innovative solutions, and this is using Autodesk software, UAV, hand scanners, SLAM scanners, to provide a variety of manufacturers to provide value-added solutions for engineering, architecture, surveying, construction, rail, fleet management, committed to supporting our clients and are passionate about understanding your needs, challenges, and current technological goals. In this webinar, we're going to give an introduction to the XGRIDS LixelStudio K1 scanner, as this is going to be a BIM to reality capture website or webinar. We're going to talk about one of our products. We're representing the XGRIDS K1 scanner. We'll talk about best practices with SLAM scanning, importing that scan data into the LixelStudio processing for cleanup, for exporting that scan data to Autodesk ReCap. And then John is going to take that over and he's going to talk about importing that into the Autodesk infrastructure world, into ReCap Pro, doing the modeling in ReCap to prepare it for importing into Revit, and then creating those Revit family and model data in there. And then we'll have time for questions and answers. If anybody has any questions, we will answer them at the end of the webinar. And then we'll go from there. Okay, so I'm going to talk about this portion of the XGRIDS LixelStudio K1 SLAM scanner. So we used to be working with other previous SLAM scanners, and this is just an option. The workflow that John is going to go over on the Autodesk side could be from static scan, it could be from UAV scan, or other type of scan products that we represent. So we're going to talk about SLAM. What is SLAM? SLAM stands for simultaneous localization and mapping. It is a type of scanning that enables the device to perform 2 tasks at once. The localization, figuring out where it is in an environment using those inertial measurement units, the gyros, the motion sensors, the tilt detectors within the actual scanner head, as well as the built map of the environment. So as it's scanned and picking up data, it is also registering that data live using both things that it has seen from different positions to kind of make sure that so it's a continuous registration mapping type of product. SLAM uses sensor data like from cameras and LiDAR to identify features and its surroundings. So an introduction to the XGRIDS K1. The LixelStudio K1 is a handheld scanner that uses the SLAM technology to create real-time 3D models of environments for applications like surveying, property capture, and digitizing monuments or other type of features. And you can see by the short video, the fast video that's playing, it is a small handheld unit. Looks kind of like a little Thor's hammer there. Don't use it like one, obviously. And we'll go through the different features of the model, but we can see how quick it is to just walk around, capture that data as you're looking at it real time on a phone app to start and stop the scan and then take it out for processing. So this is an image of the actual scanner. It weighs, it doesn't weigh very much. I like to liken it to a big, a tall boy or something like that in weight. It's easy to carry around. Your arm won't get tired doing this. 1 kilogram weight. It will colorize the point cloud. It has a 360-degree scanner LiDAR at the top, and it's very convenient. It is not, its IP rating is fairly light, but you can take it into most environments as long as it's not actively raining or dust in the air. Obviously, you wouldn't want to scan during dust anyway, because that would obscure the actual LiDAR. So it's compact and lightweight, real-time color and point cloud, panoramic capture, and it's convenient operation. And so the item there, you can see at the top would be that LiveOx LiDAR. It's a 180-degree dome of LiDAR. The scanner itself, you tilt it forward a little bit when you're scanning, and that's going to get your ground objects as well as other objects that's scanning. Internal measurement units, the IMU, that is the actual gyros and tilt meters, accelerometers that maintain that shows you that trajectory that it is going, including tilt. It has two 50 megapixel 360-degree panoramic cameras. Now each one is 180 degrees, but they will provide you with a 360-degree pano. So as you're capturing every second, it's also collecting video data that it converts to panoramic images that you can overlay on the point cloud as you're looking at it. So as you're taking measurements inside the software, those panos will show up, as well as the battery. The battery's in the handle. A typical unit comes with two batteries. They last a long time. One single battery will last almost 2.5, 3 hours. The amount of data that you can scan even on a single battery is astronomical compared to some of the other scanners. And it's an easy click on, click off. I mean, it's held on with a magnet and a clip, and charging takes place very, very rapidly. There are additional options for this type of scanner as well. It comes with the ability to have an extension pole that you can mount it either above your head, or you can flip it over and mount it so that you can drop it down into a vault or other inaccessible space below, or again with the extension pole above, getting that interstitial space above a drop ceiling. It also has the ability to tie into an N-trip with an RTK. So as you're scanning your building, you can start along the outside and take the exterior scan. Use an N-trip like Kentucky cores or MoDOT cores as your correction source, and get real-time kinematic. That means your scan is going to be geolocated in real geospatial coordinate systems. As you move indoors, then your interior scan is also going to be tied into that same coordinate system. And it also has a phone mount. You're going to be operating the scanner and getting a real-time display of what you're scanning on the actual app. And it works with both iPhone and Android. So there's not a worry about which operating system or which type of phone that I'm going to be using. Overall accuracy, it says 1.2 centimeter. That's going to be a local accuracy. Global, it's going to be a little higher than that. When I mean local, like interior room, but across your site, it may be a little bit more than that. I want to say that the 3 to 5 centimeter, or maybe more or less than that. We'll say plus or minus 200,000 points per second. Has a 40-meter range on that scanner. 1.5 hour battery. 48 megapixel. I said fixed 50. Sorry, I rounded up. It should be 48 megapixel cameras, and then a kilogram in weight. Use cases are going to be architecture, construction, interior documentation, as-built surveys, progress monitoring, BIM integration, infrastructure, volume calculations, stockpiles, mining surveys, taking it down in underground, facility documentation, real estate and property assessment, renovation planning, we'll say construction monitoring, forensics, public safety, crime scene documentation, accident, artifact preservation, museum organization, historical documentation, ecosystem, climate impact, and habitat preservation. So wherever you need scan data in a quick format, something that's very easy to scan, that's where the case is. We are going to present, we'll talk about this a little bit more. We are actually going to do a case study with this. So be prepared for an email or an invitation to that case study documentation and webinar when that comes out. Okay, the typical use of this, you're going to connect to the scanner. So again, it's going to use an Android or iPhone with the LixelStudio app. You could choose a Bluetooth connection, so somebody else can be holding the phone or iPad or whatever tablet device you're using that's running the app, or you can use a hard cable to it, in which case the batteries will work, help keep your phone charged. Create a project, start your scan. You're going to complete your scan back at your starting point. So typically you would do a looped scan. So if I was doing an exterior of a building, I may start outside, walk around the exterior of the building, walk in the open front door and start my internal scan. And when I'm done with my scan, typically I would come back out and stop the scan at the starting point. It's kind of like closing the horizon with an instrument. It's just making sure you close your traverse. But with the RTK antenna down there at the bottom, you can do open scans. So if I was doing, let's say, a corridor scan of a tunnel, or someplace where it's not convenient for me to loop back around, I can use the RTK antenna, start exterior again, walk my route, and then as long as I have the ability to tie it in at the end with that, it will help fix that SLAM algorithm. The SLAM algorithm can drift over time if you don't have a check. The unit also allows for ground processing, ground control points. So you can set this on a known target. If somebody's gone ahead and surveyed control points throughout your site ahead of time, you can actually incorporate those points into your scan to help with both a correction and a local site calibration. So if I was on a local coordinate system, I may have a local XYZ for column lines or points or other key control features. I can incorporate those into my scan to make sure that my scan fits into that proper coordinate system. So you can see kind of like a couple diagrams there. We're going to plan our scan ahead of time. It's good to make sure that there are no obstructions, and I'm not going to be standing there waiting for objects to move and get out of the way. I'm going to open doors and drop ceilings ahead of time. So in scanning a building, you want to make sure the doors are open. At least most of the way you can reach behind the door. It's kind of like to remember that it's like shining a flashlight. As long as there's an object in the way, it's not going to see behind it. So if I need to get behind a door or behind a desk or object, I'm going to have to reach around that object to shine the scan at it. Check for proper lighting is required because those two 48 megapixel cameras are collecting 360 pano data. It's going to use that to colorize your point cloud. So if you're doing it in darkened conditions, expect your point cloud to reflect that. Plan your travel path, avoid too much duplication. Don't scan the same thing over and over and over again, although it will compensate for that. You know, if you shine it at a wall for a minute, it's not going to collect 200,000 points indefinitely out of that wall. It's going to start dropping those points into processing. Loops within loops for better IMU processing. So that bottom image on the right there shows how we're looping around in small increments to make more of a path for the internal sensors. Remember blind spots. So that's what I was talking about, making sure you're reaching behind objects. 30-minute max per scan. So as fast as you can walk in 30 minutes, that's how much you can scan. So if you need to, you would break your scans up into multiple scans in those 30 minutes. So like if I was going to go internally to these buildings on those images, I would just make sure that I would do an initial scan and then overlap my next scan. So if I was going into, let's say, this top building here, I would start outside and collect some additional outside data as an overlap, and then walk in my building to start my internal scan. That lets me register these two scans together as multiple scans. So in the software, we would process each scan independently, and then we can use the merge tool to merge them together into one unified scan. But to help us do that, we need that 20% overlap. So the processing is done in one of two products. So the default program that comes with the scanner is called XGRIDS LixelStudio. It is a perpetual license with the hardware. There's 3 perpetual licenses that come with it, and they're good for the lifetime of the scanner. And it is based upon cloud compare. So we're processing SLAM to the last file. Import, process your raw data, utilize RTK or ground control or point georeferencing if you use control points. There are analysis and cleanup tools. There's the panoramic viewer, and then we can export directly to ReCap, E57, or LAS. Or optional, there's a secondary program called Lixel CyberColor, which processes the multi-SLAM to a 3D Gaussian splat mesh. So used to process the same raw data. I don't have to make a a determination of which software I'm going into, one scan will go into both pieces of software. Measurement and area tools in this, there's a cloud sharing option or a standalone free viewer. So if I was to show this digital twin to an outside stakeholder, they could use this software. I can share this over a web browser, and I have one shared. We'll see an example of this, and John will show you what the shared version looks like. But this software does have a paid subscription that goes along with it. So processing, again, we're going to download the scanner. Once the scan is done, there's a micro SD card on the scanner, or we can hook it up to USB-C and download the raw data. Every scan is its own independent folder. We set up a new project in LixelStudio. We add things like our RTK settings. We make sure we can do a transformation to a coordinate system that we need. Otherwise, it's going to be in a UTM coordinate system, and then we'll process that to a LAS. Okay. There's also cleanup, analyzing, and exporting this. So there are tools in there where we can look at the panoramas, take measurements, do some basic cleanup, and then exporting those tools out. Okay. Denoising, smoothing, area and volume click, panorama viewer, the slicing tool, measurement and volume, and then export to LAS. All right, so I'm going to go ahead and show you that the data here. So we opted to scan, and this is going to be part of our future case study. This is a local building. So this is the LixelStudio software. It's a very lightweight piece of software. We can go into a dark or a light mode here. But it's as simple as saying, hey, we started a project. I go to my project processing. I will just go to wherever I keep my data. So this is the one I brought in. I'm going to select that folder. I had no ground control points, but if I did, then I would download those and I would import my own CSV file and just match the points, point 1 to point B, A, point 2 to point B, points 3 to point C, etc. Or I can look at my RTK module. It's going to tell me, how many satellites I had, what kind of trajectory was internal versus external, and then what coordinate transformation I want to send that to. I decide whether I want to colorize it and whether I want to start to do. I can add point cloud enhancement. I can make it a grid format, or I can subsection this out. And I just hit start and walk away. Processing time is typically 1 to 5 times the scanning time. So for every minute of scanning, I can expect 1 to 5 minutes of processing, depending on your computer specs. Now I've already run that once, and once done, you're going to get that scan in. So this is the building. This is a local Frank Lloyd Wright House in the St. Louis area. So this is perfect for this kind of odd-shaped building where I'm able to walk in on this and see the scan. So it has a built-in point cloud viewer, and for every one of these scans here, I can look at them in RGB and elevation mode. I can turn on the shading. I can also look at this in an intensity mode, over GPS time, or by classification if it was classified data. I can also import in any type of data. So I can come back here in a file and import any LAS. So combining this data with a UAV processed, maybe it was already ground processed, I can merge the two together into one single. So I'm not limited to just Lixel stuff in this software. I can bring in any LAS software. And then when I am looking at this, let's go back to this. Let's say I go by an elevation mode. I can change different palettes depending on what I need, change point size here, and then I can go to this X-ray mode, which is kind of a mode you'd see. Let me go to a dark. We have other software that will go to X-ray. So X-ray mode kind of gives you an overall feeling of objects that are behind and how certain features are related to other certain features. Okay. There are other tools in here. So once I do have my point cloud, let me go back to RGB. Once I do have my point cloud process, there are additional cleanup tools here. There is a profile analysis, a clipping box, a clip, a panoramic overlay. Go to the panoramic overlay. And then all I have to do is point to the output data, results, and select folder, and now I have my panos. So with those 2 cameras that are on there, I'm collecting data, as well as, let me choose one here by these steps. I got some steps right here, right? I'll turn off that trajectory. So here you can see I have the point cloud. I have the highlighted trajectory point that I'm looking at it from. So every one of these arrows is a panoramic photo. Turn off that trajectory. I can turn on the point cloud. So now I'm looking at the image overlay with the point cloud. And then all the items that I have with the point cloud, looking at this in elevation view, I can apply like a transparency to that so I can see the image and the point cloud overlaid. I can turn off the point cloud, look at the image, or I can turn off the image and look at the point cloud. So that's going to be my view for that particular area. Okay, and I can take measurements in this view. So going back to, let's go back to just a RGB. Let's increase that back up to 1. Let's turn on the image background. So there are basic measurement tools in here, like point. If I wanted to point elevation, I can just say point, pick a point on mine and get your and then give the information about that point. Take measurements in here, angles, distances. You know, I want to know the width of these steps. I can use the little target to help me make sure that I'm collecting that along. Right, and get lengths and take measurements in here. Then I can take photos. I can save these out as photo snapshots, or I can actually just walk through the scan as I scanned it too. So you get an up-to-date view of items that I'm seeing on this panoramic. I'll stop that. Exit that. We also have tools here for aligning multiple point clouds together, clipping different point clouds. So if I look here, I have some other options, like if I wanted to go to the horizontal slice, I can create a horizontal slice in any mood. Let's actually go to a vertical slice here. Okay, vertical slice. So if I wanted to take, do a section of the building there, I can see that, get a preview of it, and that's what my slice would look like in the preview. And then I can save this out as a new image or new point cloud slice, change my thickness, etc. Okay. So these are the different items that are on here, and that's the color programming here. The secondary tool that I showed you here was the Cyber Color. So this is the Gaussian splatting. See, I had several projects in here. As I open one, this is going to give you that same processing data. I just say create a new project, bring that same data into this folder, go into the Cyber Color tool. And then in that tool, you can see I have that 3D Gaussian splatting. So what I'm actually looking at here is a point cloud object that has been turned into a Gaussian splat mesh. So it is a mesh tool used to turn this into a mesh item. You can see there is the underlying point cloud that makes up the mesh. So it's a combination of using the photogrammetry from the cameras plus the LiDAR to create a highly accurate mesh model. Okay, and then this could be shareable. There are rectangular and measurement tools in here. There's a clipping box content in here. I can start and clip areas in here, change depth, change thickness, and get new views. I could take measurements in this tool as well, so roof to ground or something like that, and get those measurements. And then I can share this out. Anytime I can save this out as additional assets, go back to my starting point, switch, use some brush tools, change the skybox to match my environment if need be, and then export this out. So back on my toolbox here, I can share this. And when I export this out, I can either upload this to a point cloud, or I can save it to LCC, or I can use the official Splat PLY file. So there are various formats that I can export this out. What I've done is I've opted to export this out to the North American LCC viewer. And I copied this link and I sent this over to John, and John can show you what that looks like on the web as it goes. So with that covers the scanning and the processing. So again, just to highlight, scan the area very quickly. We use the SLAM scanner. Use your processing tool here on LixelStudio to process out a standard LAS. Then we're going to go ahead and export that out to RCP format, to E57, merge items that we need to clean up and denoise in here, or I can opt to clean up in Autodesk ReCap. And with that, I'm going to stop sharing here, and I'm going to give presentation over to John.
Okay, thank you much for that, Mark. My name is John Ofield, as Mark was mentioning earlier, and so this particular portion of the webinar is going to cover the use of the Autodesk ReCap Pro and Revit workflow from what Mark has used with the hand scanner prior. And notice Mark didn't say anything about, oh, I need to export a particular file format out. It's because we're going to go through the different file formats of what we can use and what will best work in this particular workflow here. So as Mark did show earlier when he exported this out, this is actually what that link looked like. So I just opened it up in a browser. You can see what that point cloud with that photogrammetry overlay looks like, but it does come with a toolbar available that you can turn on and off the photos or the point cloud portion. You can come in and do measurements just like Mark was showing as well, markups. You can also come in and change perspective, pilot avatar mode like Mark had iRobot guy out there. And then also if you need to change some settings like, hey, maybe I didn't have Imperial turned on and it was only showing metric when we're doing measurements, you can change that here within the settings as well. Rendering components, maybe it's a little sluggish on your computer, you can change that for performance versus quality, and then also your environment settings here. But then if you wanted to see what that trajectory was, we'd just turn on that scanning path and you'll be able to see all of those areas that was used within that scanning portion there. So the next item is, what do we do? Well, it's the transition into the Autodesk workflow that's going to make your scans really start to come to life. We're going to use this in many different formats. It's you know, digital twins, it's maybe reconstruction, it could be for new construction, it's just about anything. But to utilize point cloud technology in our software for modeling, detailing, whatever it might be, has come a long way. And so we've even got a few items like a particular plugin that we can utilize that's called ReCap Mesh plugin, and that will actually allow us to bring that mesh in from ReCap into our Revit using categories to make these components out of this point cloud mesh into content within Revit. So we're going to take the software, Autodesk Recap and Revit. We're going to find out what type of point cloud files we can use, LAS, LAZ, you know, many different formats. And then ReCap is actually what's going to convert it into an RCP ultimately for us to use. You can also convert those as well in other software to the RCP format, but it's not really needed right off the bat. We're going to go through that meshing and export, utilizing the plugin to bring that in Revit, and then how to insert that into your Revit project. So creating a new recap project, well, we're going to import an LAS into this project. What's that process look like? Navigating, managing the point cloud here. So as I open up Autodesk ReCap Pro here, you'll see this, that is the point cloud that we did bring in. ultimately, we want to just start off a brand new project. You can just go into the project home, start new project. Up at the top left, you're going to pick, is it import point cloud or your photo to 3D. So depending on, are you using drone data? Are you using static scanners? Are you using handheld? It really doesn't matter. This is where I'm going to go ahead and pick that information. And then I'm not going to save that project, but this is where we would come in, give this project a name, hit proceed. And once I pick that, now notice up here it says select files to import, or you can just pick a whole folder, or you can just drag and drop your content. So when you go to do that, this is actually creating an RCP for you right off the bat. So you don't have to worry about, oh, do I have to take something, bring it in and convert it? It does that conversion process, it creates it. So any of your Autodesk programs can actually utilize this if they use the point cloud insert component there. So that's what really all of that is going to do there. I want to go ahead and cancel that. And so once that project is done, I'm just going to come in back into that point cloud there. All right, looks like my point cloud had a late night of some sort of partying, yes. Okay. So there's that point cloud there, but let's just imagine, hey, I only want a portion of this point cloud. What are we going to do? So that's where here in this point cloud, we're actually going to kind of take this entirety and we're going to just truncate it down to what we need. So this is part of that whole cleanup process, right? Well, if you go into the top portion of your view, you're looking down on this thing. You can zoom in still just like normal, but a little tip and trick that was handed off to me just recently is, hey, what if we just turn this into an ortho type view? Well, that can work. I've always done this from perspective. So you're just going to come into here to your tools. You're just going to left click on that perspective. It changes to that ortho type view. Makes everything a lot straighter and not less fisheye type view here. I'm going to go into window, and this is where we can use a typical windowing where you can just drag out a box. If you need something a little tighter, maybe it was more at an angle, this is where we would use the fence command. So I'm going to use this fence command, and you know, maybe I wanted to only just cut off a component of this house. We could do that. But here on the window, I'm just going to simply just drag this window here. And then what you want to do is, if you want to eliminate all of the stuff on the outside, this is where you got to come down, select clip outside. What that does is just gives you a nice cleaned up area. And then you can come back and you can turn on that perspective if you want. It gives it more of that natural 3D look. And see, there's a lot less to clean up now. Now, if you wanted to go get some of these stragglers, highlight them and delete them, yeah, that will work as well. So what you want to do next, though, is you want to come up here and you'll want to go into the export. And it'll export this out as a project here. And so that doesn't override any of your existing information. So there's my Frank Lloyd Wright, and I'm just going to say clean webinar. All right, so that one, and there we'll hit save. Now it's going to give you this notification every time if you haven't done this. And of course, you can get in and change some of these unify settings here, but if you want your spacing, you can adjust that. You can refine your grid. You can say no, or just go ahead and unify. What that does, it just takes it and saves it as a new project, basically. So as this coming along here, we're getting ready to start this whole meshing process and then bring this into our Revit environment. Is what do we have to do special with Revit? Well, I've got Revit open, and when we get ready to start this project, I'm using Revit 2026, but you can use multiple versions of Revit when you're doing this. Now, the differences between the newer version of Revit, the 2026, versus something like 2024. 2024, I'm not going to have that, possibly that conversion to mesh, right? So utilize these newer features, these newer tools in our newer software, and we'll be able to use everything more efficiently here. All right, let's jump back over. All right, that went ahead and exported out, saved that. Now the project is saved, it's ready. We could go open that up, sure. I mean, all I gotta do is just start a new project. Let's jump over here. I am now in Autodesk Revit here. It is opening up just a basic template. Now, I do recommend that you create specific items within a template if you are going to use point clouds often. It just helps with certain features. And there are also some additional add-ins to the XGRIDS software that will allow you to pull levels and model particular components, but I'm going to leave those alone for right now. So how do we bring this point cloud in? Well, that's your insert tab. So insert, we'll select point cloud. We're going to go find that point cloud we just created. It could be the small one, could be the full large one, depends on what you're needing and what for. And it could also be multiple point clouds, right? So just like any other Revit file, I'm just going to pick my origin to origin, select that file, and there we go. Let's go take a look at this here in our environment. Yep, that's that cleaned up portion. I don't see all the trees or all the other topo in there. Okay, now did this mesh it out? No, not yet. So let's run back over to recap and figure out what that process is going to be like. Well, I want to jump back into this top view, and we're just going to chop off a portion of this house here. So let's go back in that ortho type view, and I'm just going to use this fencing tool here. So I'm just going to tell it to have starting points, and notice that you can, pick wherever you need. Double F click to stop that or closes it out. You'll see this opaque area, and that is the part that is going to be cropped. So now if I clip outside, notice that is available for that. Turn this perspective back on, and here we go. Now, we still haven't meshed, but we have a particular portion of this project that we are wanting to use in this meshing capability. So that's where we go down to the bottom left. And you do have two types that you can do. You can use, if you have your tokens or flex token credit through Autodesk, you can utilize this for rendering in the cloud, for doing the point processing and this meshing. But I'm just going to select local. Now you're going to notice it'll ask you to save your project. And we do have some capabilities of changing, how do we know what type of scanner? Well, the software doesn't know exactly, so you can come in here and change this. So we notice it was a handheld, if it was a wearable, if it's just terrestrial, vehicle-based, or something from a drone. So I'm just going to pick handheld slam. Here's your high, medium, density for that meshing. And you can also customize these settings here as well, as you see. So I'm just going to leave it as is. We're going to hit submit, and then you're going to see this start to process. So as this is running through, notice if you do ever have questions, it does have a nice hyperlink for the user guide down here. Then you can go through and use keywords to allow that to find certain components here as well. So as we're using this local meshing, notice that the mesh editor button now will populate. So if you don't have a point cloud that has been meshed already, you will not see this option until you are finished or have started this process. So we'll wait and see what that looks like here. So you'll see the converting tiles processing, and this is almost done. So I'm going to run back over here to our Revit software just really quick. And these boxes that you see, these were just some of the default scope boxes. I'm just going to go get rid of those here, and we'll get those shut down. And so there's those scope boxes. We'll turn that off so we don't have anything else wrong there. But yes, if you wanted to change anything else about this, that point cloud, notice that you can come in once this has been inserted into the point cloud tab within visibility graphics. You can change that from the RGB to your single, elevation, intensity, and normals here as well. So maybe I forgot to put it as intensity when I export it out. You can definitely change that once that is in there. All right, let's run back here to our recap software, and it is almost done, as you can see here at the end. Now, another thing that I've noticed is when you are ready to start meshing these point clouds, think like Mark was explaining earlier, you want to kind of have a roadmap of how you want to attack your project. You want to have a roadmap of what you're going to, how you're going to cut this project up, possibly. So if you get something like a house, yeah, I could mesh the whole thing. It would take a bit to mesh it, but it's not as bad as, let's say, selecting an entire hospital project and doing that. So that's why you want to take these in chunks if you possibly can there. So now it is completed. We have opened a mesh editor. So that's still within our ReCap Pro software. And you can even see here, the file actually looks a little bit different here. Well, it's because it actually has gone through and started meshing. So that kind of clean, picturesque point cloud that Mark was showing earlier in the other XGRIDS software, it did that meshing as well. It kind of gives it that nice, cleaner appearance here as well. Okay, so I see we've got some walls, we've got a little bit of topo, and if I spin this thing around, yes, we see partial interior. Well, it's just the hollow because we didn't get the interior of this project linked in here, but that's okay. We can link those in at any point in time and do this. Now, what do we have here in front of us? Well, notice that all of our program basically changed as soon as we meshed it out. So up at the top, we're going to kind of go through, is it the model browser we're taking a look at? That's just the dialog boxes here on our left. We also have your properties, which is over on the right there. You do have your toolbars over here too, so we can come through, we can orthographics, perspective view, if you want to come in to create fencing, saving, and then export here. But this is just listing the name of our point cloud that we had chopped off and brought in, and this is the tile for that. So that tile is really just the information that we had just clipped there. So down here at the bottom of this, we have a couple of buttons that are active, and we have add group and add layer. So if I had a similar grouping of components, let's say maybe it was structural components, and maybe I could do columns and beams and rafters and floor joist and maybe walls, I could create a group and call that, you know, my structural components. Whereas if I was just creating one-off items, I would just add a layer. And this is kind of like adding layers in your CAD environment. I mean, how do we differentiate between components? That's this right here. So maybe it was walls. Okay, I'll hit enter there. And notice I don't have to select anything right off the bat and do roof. Okay, so walls and roof, oh, you can just, you know, drag and drop. See? You don't even have to delete and rearrange or do anything. You can just simply drag and drop this stuff. Can we change color of items? You sure can. There we go. We'll see that. Now the items are already meshed. So let's go see what this looks like. when I go pick a wall, notice it is actually picking that wall. Well, what it can find, it may find a few stragglers, so yeah, may have to come back, may have to window across, but that will grab the rest of those points that were not actually meshed in. And maybe we just need to change that meshing capability. You know, we can bring that point value down just a little bit tighter so it can find those items. Maybe I want to add some additional wall components. Okay, here we go. So there are those items. Let's go see what we got over here. All right, so all of these items, like these walls here, how do we go add those now to that wall layer? Well, that's down here at the very bottom. Notice that we have classify available, merge and classify, and then we got a couple others on clear selection or escape. You know, escape is always our good friend there. Hide selection here as well. Maybe you got some things that are in the way. You can select things and hide them so you can actually go through maybe window bigger portions and add those to your categories. But let's go take these and add those to that wall layer here. Okay, so structural roof or wall, and that you see how that is listed here. Okay, and now we're going to come down here at the bottom and we're going to select that merge and classify. So now that purple color for the walls that we see here is now being applied to those components. Now, if I do this with the roof, and you know, if you took a little more time, or I got in here and started adding, you know, better cutoff component areas, we could do that a little bit quicker. But now we can start seeing how these components are actually working. So if I wanted one for windows, one for doors, one for bushes, one for driveway, you know, all sorts of different things that you could do. Now, this information is really important because this is now coming over as categories into Revit. I'm sorry, I'm running a little bit slow over here on this component, but this is our next one. So let me jump over to that, and we are going to export this mesh out. We're going to use this for the classification and converting into families now in Revit. So once you're done with that, you want to go ahead and hit save. You do want to export, and this will export as a .rcmr. Now what that means is that's that recap mesh Revit format, and this is something specifically Revit will pick up now. So I'm going to go ahead and make sure that that is going to the correct location. There we go. And we'll say use now. Okay. Oh, there we go. Okay. So classification color, you can say none or on here as well, but this, everything with check mark is going to be exported out. So that was a really quick export process there. Let's go take a look here in Revit. How do we bring that in? Now you'd think, hey, let's go back to that insert tab. You do have to make sure that you have this recap mesh plugin tab downloaded. You can get this from your Autodesk manage.autodesk.com. Go into your account and download that from your program and updates there. Link recap mesh model. We're going to select internal origin, just like we did with the model setup itself. We're going to select add. And now we've got our scans here, and there is that .rcmr here. We'll open this up. We're going to make sure that that is active. We'll select OK. So the reason we don't see it, but I do see this like bounding box right here, and it knows where we clipped it from, is because those check marks are not turned on. So I could do that for the entire thing here. Let's go take a look at that without the point cloud. So here's that point cloud. Let's go turn that off, and we're going to select OK. So now there's just the roof there. Uh-oh, what happened there? Well, I did want to show one little thing is when you are creating those particular components, like the wall and the roof, we just got to make sure we do have that saved out as those components. Otherwise, you may accidentally put everything on, or if you did not grab one of those categories, well, those categories will not come across. Okay, so I'm going to take this category and notice that we got show all, we've got hide all, so it's kind of like coming over here to this dialog box to show or hide those items. And we've got the hide panel here as well. Now, with that, all we have to do is select those items here. And if we do that, we've got that unclassified, so I could turn that entire thing on and off. Let me just try this one more time here. So I've got my entire mesh and visible mesh. We'll go ahead and just go over that. Notice how it did put it as a 1. So you can come back over here. We can do add model. We're going to pick that newest one. Let's select OK. I'm just going to pick that one there. And notice that you can remove an older one. You can also reload here. So it makes it really nice. Okay. So now there's our walls and our roof. Perfect. Okay. So we're just going to take this one. Notice I've got my Revit, and then my walls and my other components here. All right. So turn this one off. Let's go back over here and see how we've got those different items that we can select. Now, when you have an item selected there, notice that we've got up here in our ribbon, add to document. What that allows us to do is take that category or that classification, let's say it was wall, I can now turn that generic model into a wall here. Well, not window, walls. There we go. So equals wall. I could do, roof equals roof. You could see all from all the list. It's everything within Revit listed in here. And now we've got this process that allows us to have that component done. You can also make that into families and things of that nature, but we're going to leave that for another day. But with that process, it's really slick to be able to come in, I want to see things, I don't want to see things. What do we want to do with this? I want to promote this to a family. Okay, well, what level do you want that on? Things of that nature. And it's just an easier way to take your point clouds, actually convert it to a mesh, and then actual categorize it within your model within Revit. Makes it really nice to be able to do that. All right, well, I'm going to throw this back here to Mark here. I know we have a few minutes left. We got some questions and everything as well. I appreciate everybody's time. So here you go, Mark.
All right, thanks, John. So that is our presentation for the day. I mean, it's a lot of information to try to cram into a single hour. We always tend to run up against these type of obstacles. But with that, I just have a couple more items. So I want to thank everybody for coming into our webinar today and participating in this. So you can see how easy it is to take scan data and turn that into mesh models to bring into Revit to start, and you can use those mesh models for creating your family components for your digital twin. At this time, we'd like to open the floor for any questions if anybody has any. I don't see any that popped up in the interim. I'm keeping my eye on that. So if anybody has any questions, please go ahead and ask them in the chat box. And while we're doing that, I just wanted to show one more thing. So John has put together a blog post on this particular Revit workflow. If you'd like to gain access to that blog in an easy way, here is a quick QR code. That will take you to that actual blog post on it. With that, I got a question here. Can we see the quality of the wall that was brought into the Revit file? Did it come together as a whole element or a lot of different walls? John, do you want to jump on the mic and answer that one?
So the question with the wall, it will not come in as a wall because walls are system families within. So it's just taking that category and giving us a placeholder for that component as it comes across there, if that makes sense. On the wall question, it says quality of the wall is brought in a Revit file, and then did it come in together as a whole element or a whole or a lot of different walls? So once those are categorized as wall, it's just wall. You can see that up here in the properties, but the quality of it, it's coming from a point cloud. It's just a mesh, and remember, this is only one face of the wall. The interior was not done, so there is not what we would see as a thickness value. It's just something that we could take into like a top and or side view and use that line work to then, snap our lines when we're using the draw walls, the snap lines or anything like that, and just verify it we're on that particular plane. Now, the other part of the question is it one element or all different? These are actually all grouped together. So if I needed each wall separately, like north wall, south wall, east, something like that, that's where I would regroup those back over here in recap. And I would just say, north wall, west wall, south wall, whatever it might be. That way here in Revit, on the right-hand side, I could turn those on and off as needed. So, yeah.
So thank you. Tim Johnson asks, what is the vertical accuracy? So it's not like, because it's a LiDAR-based unit, it's not like it would be in photogrammetry where we have a ground sampling distance and a plus minus vertical accuracy. It's a 3D LiDAR scanning. So local accuracies are going to be in that 1.5 centimeter range of the scan head. So that your vertical accuracy is going to be the same. It's a 3D overall accuracy. It's not a vertical accuracy. What is the near field capability of the handheld scanner? It's from Chris Bunton. It is, you could dial it in. I think the default setting is going to be a meter bubble that kind of keeps your body out of the way. So if you're trailing along with a buddy that's holding the phone or something, you'll get what we call the slam trail or the slam parade, especially when you got a group of people. Now the software is set up so that when you're processing to remove those transient objects. So as the slam scanning is going through, as you're seeing people in the raw data, when you get to the process, most of them will be removed. You can dial it down, so there's like a narrow tunnel. Let's say I'm putting this through a manhole or a smaller tunnel. There is an algorithm that brings that bubble back into 0.5 meter. I think you could dial it in less or not. I would have to check on that. So it's going to be a meter by default, 0.5 meter for confined spaces. Is that placeholder snappable after then? So Jay Stoddard asked about your placeholder. So that is that mesh model snappable in Revit?
Yeah, so you can use the survey or project base point as well, but you can, or if you need to use like actual coordinates or anything like that. Does that put that question there?
Can you if you're drawing something, can you snap on that mesh with your cursor?
Oh yeah, so just come back over here, like either with annotate or even an object like a wall, and see how it's actually finding, because it's actual points. It's it is the point cloud itself. So yes, those points are snappable there.
Okay, good.
Otherwise, it wouldn't.
A couple more questions here. Jared Bruner asks, can you explain what meant by GPS time? So at GPS time, let me go back to my screen here really quick. When I look at it let me turn off these other ones. So I look at this point cloud by GPS time. That's just, let me turn to a better, there we go. So the color bit basically says the blue is the low end. That's where I started the scan. So anything you see, let me go to a Z-lock. So the blue area is where I started my scan. And you can kind of see as I pull this out, it's basically the path that I chose when I'm scanning. So it's just a rainbow. Blue is where the beginning of the scan is, the outside. So that's the GPS time. I had the RTK antenna going on. So if I look at my trajectory, so basically it's the GPS time. As I started the scan, I had the RTK antenna on, it was collecting data, and I'm moving through the trajectory. It's just a colorization of, hey, this appeared at this time. It kind of shows the path that I walk through. That's all that is. Does connecting to, yes, that's basically, Jared, yes, it'd be a QA. If you see things going off, you can say, okay, look, I lost RTK connection at this time or something like that. You can go back through when you're processing, and you can say, okay, maybe I have a bad satellites, or it's below a threshold, or there are obstacles in the way. I can say, okay, let's change the threshold down, and you'll see pieces of that RTK disappear. When that along that pathway where it's collecting data, it's going to go 100% SLAM instead of using the RTK data. So it'll use whatever is beginning and the end. That's actually for. What would I say the RTK antenna is recommended for accuracy? Jay Stoddard, though, it's going to be a mapping grade. It's going to be 1 to 3 centimeter accuracy. It's not going to be sub-centimeter by far. It's not that. It's more like drone-based mapping accuracy. All right, we're running a little over on time. You're very welcome for that. I think that's all the questions we have. With that, I'd like to thank everybody who came. So again, if you want to get that QR code, take you to that blog post. We can include that link in a follow-up. I advise everybody, please, after this webinar, you're going to get a survey. Please fill out that survey on the content of this, as well as for suggestions for future webinars. We'd really appreciate it, and appreciate your time. With that, that's all I have. Thank you very much for coming. John, thank you for being along here with me.
All.
And you all have a wonderful day. Thank you very much.